Welcome back, guys. In this video, we have to figure out how does each transformation here, so we got 6 transformations, affect the number of zeros for two functions. F of x equals x squared and g of x is x squared minus 2. So before getting into the transformations, I'm actually going to graph both of these. So we have f of x equals x squared. Let's start with this one. That's just a basic quadratic, like this, right? So how many x-intercepts does this quadratic have? It has one x-intercept. It's just the vertex, right there at 0 and 0. So that is f of x equals x squared. What about g of x equals x squared minus 2? Well, this quadratic is going to look how? X squared minus 2, we can rewrite as x plus 0 squared minus 2. Remember when I told you that there's no b value, that the vertex is always going to be 0 and the c value? Well, 0 and negative 2 is going to be the vertex, and this is going to be opening up because that's a positive one. So notice this quadratic, g of x, has how many x-intercepts? It has 2 x-intercepts. So that's what we are originally dealing with. X squared has 1 x-intercept, g of x equals x squared minus 2 has 2 x-intercepts over here and over here. We don't actually have to know what they are, but if you do want to know, it's the square root, plus or minus square root of 2. Right? When we plug in 0 for y, bring the 2 over, square root both sides. So we have to figure out if both of these functions go through these transformations, how is the number of x-intercepts going to be affected? What's going to happen to this one x-intercept? What's going to happen to these 2 x-intercepts? So the way I'm going to actually do this is with a table. So I'm going to create 2 columns here. One is going to be for f of x, which is x squared. And then the other column is going to be for g of x. So let's start off with this first transformation here. This is a vertical compression by 1 over 3. So you're taking both of these graphs and you are just compressing them. So if this is x squared, vertical compression by 1 over 3, it's going to look something like this, right? And then this one, it's going to look something like this. It's basically going to be a little bit wider. So notice that the x-intercepts, the number of x-intercepts stay the same. This is still going to have 1 x-intercept, and this still is going to have 2 x-intercepts. So a vertical compression or vertical stretch, it actually never affects the amount of x-intercepts for a quadratic. You may want to write that down in general. Vertical compression or a vertical stretch doesn't affect the number of x-intercepts. And actually a horizontal compression or stretch doesn't affect it either. Right? What about the other transformation? So what is the next one? Just a sec, let me erase this here. So we're going to take these quadratics and we're going to shift them 2 units up, translation 2 units up. Well, if we take this quadratic, shift it up by 2 units, then the vertex now is going to be at 0 and 2, and it's still going to be opening up. So how many x-intercepts are there going to be now? There's going to be none. Right? It's never going to cross that x-axis if we take this and shift it up by 2. So this here, it's going to have 0 x-intercepts. What if we take this and shift it up by 2? Well, if we take this and shift it up by 2, the vertex originally is at 0 and negative 2. So if we shift it up, the vertex now is going to be at 0 and 0. It's going to be here. So it's going to look like this graph, the original x squared graph. It actually is going to be the x squared graph because you're going to have x squared minus 2 plus 2. So there's going to be 1 x-intercept for g of x in that case. right? So vertical translation, up or down, doesn't necessarily always have to affect the number of x-intercepts, but a lot of times it will, like in this case. What if there's a translation 2 units down? Well, notice with this one, if we take this, translate it 2 units down, we'll actually end up with g of x. We'll have x squared minus 2. So that will be 2 x-intercepts for f of x. If we take this, shift it down, it's going to go through the x-axis twice. What about g of x? Well, if we take this and shift it down by 2 units, the new vertex is going to be at 0, -4. Still going to be opening up. There's still going to be 2 x-intercepts. So there's actually going to be no change for g of x, but there will be a change for f of x. A reflection in the x-axis. What that means is we're just going to be taking these and flipping them. So this is going to open down now, and then this is going to open down. So this here, vertex is still going to be at 0, 0, opening down, 1 x-intercept. This one here, it's opening up, now it's going to be opening down. If the vertex is at 0, -2, notice it's never going to cross that x-axis. So there's going to be 0 x-intercepts in that case. A reflection in the y-axis means we're just going to be flipping it horizontally. So notice in that case that there's not going to be any change because a quadratic is always symmetrical. So we're going to end up having the same quadratic if we reflect it in the y-axis. So there's not going to be a change. There's going to be 1 x-intercept still going to be 2 x-intercepts. And then a translation 3 units left. If we take this, move it 3 units left, that would be here. So this would be at -3 and 0. Still only going to be 1 x-intercept. If we take this, move it 3 units left, it's still going to go through the x-axis twice. So that's not going to change either. Right? So those are your final answers right there. So I did them sort of visually. Hopefully that made sense. So when they give you functions like this, first thing you want to do is you want to graph them. Right? Sometimes there'll be easy functions like this. Sometimes maybe you'll have to complete the square, know where the vertex is, know whether it's opening up or down, then see, is there 2 x-intercepts or 1 x-intercept? And then from there, once you have the original graph, you can just sort of visually see how transformations are going to affect it and affect the number of intercepts. So these columns here represent the number of intercepts that these functions will have if they undergo these transformations there.